In the spring of 1943, Europe was locked in a grinding war of resources. Steel, power, and water determined victory, as much as soldiers and tanks. Hidden within Germany's industrial heartland stood massive dams, quietly feeding factories and armament works. To British planners, these structures became more than concrete walls. They were pressure point, targets that could break an enemy's ability to wage modern war. Among these targets, 3 dams stood out along the Ruhr Valley. They controlled water, electricity, and industry for millions. Destroying them promised chaos, but attacking them seemed impossible. Heavy defenses, narrow valleys, and sheer concrete faces mocked conventional bombing. To reach them, Britain would have to abandon standard rules of air warfare and invent something entirely new. The issue was straightforward yet harsh. Bombs dropped directly downward, but dams withstood attacks from all directions. Torpedoes were blocked by nets. Bombs released from high altitudes failed to hit their targets. Low-altitude strikes faced catastrophic risks. The mission demanded accuracy, calculated in feet and seconds, rather than miles and tons. The solution would be devised by an engineer who envisioned bombs acting like stones skipping across water. This would become Operation Chastise, a mission so narrow in execution that success might last barely 60 seconds. Yet those seconds would reshape landscapes, factories, and lives. Before the engines warmed and crews boarded their aircraft, the operation already carried immense risk. Failure meant nothing. Success meant everything, and many would not come home. In contrast to widespread bombing campaigns, this operation required personal expertise. Every plane flew solo, skimming close to the ground under the cover of night. There was no protection in large groups, and no opportunity for a do-over. Accuracy would take the place of sheer quantity. Bravery would substitute for flying high. Operation Chastise was not centered on sheer power but on flawless performance in the face of unimaginable challenges. At its heart, the raid represented a balance between exceptional engineering and human fragility. The machines were pushed to their utmost capacity, while the crews were driven to their limits. The tale of Operation Chastise cannot be told without acknowledging the individuals who willingly took on an almost suicidal mission, placing equal faith in precise calculations, rigorous training, and one another. The mission would quickly gain a legendary status, but legends often hide the price. Beneath the story were fear, uncertainty, and an almost obsessive level of preparation. Even before the initial dam broke, lives were already being transformed through sleepless nights, secret blueprints, and the awareness that survival was always uncertain. To understand how 60 seconds could change a war, we must begin where it started, deep inside Britain's laboratories and training fields, where an unlikely weapon was sketched, tested, and nearly abandoned before it ever flew. The Ruhr dams were remarkable feats of engineering from the early 1900s. Massive concrete structures restrained vast reservoirs that supplied steel mills and power plants. To demolish one was entirely different from targeting a factory. It demanded the application of physics, water pressure, and an understanding of structural vulnerabilities. Expertise typically employed to construct rather than to destroy. Traditional bombing strategies failed against these monoliths. Explosions on the surface dispersed energy harmlessly. The true vulnerability lay below the waterline, where pressure amplified force. Reaching that point without being deflected or intercepted became the central challenge facing British scientists. The fortifications greatly heightened the challenge. Anti-aircraft weaponry was strategically placed around the valleys. Barrage balloons floated overhead, and torpedo nets were hidden beneath the water's surface. Operating at high altitudes diminished precision, while flying at lower levels almost guaranteed inevitable death. The dams appeared expertly constructed to withstand aerial assaults, shielded both by the surrounding landscape and their sturdy reinforced concrete structures along with defensive weaponry. Into this problem stepped Barnes Wallis, an engineer known for unorthodox thinking. Wallis believed that bombs could be coaxed into skipping across water. If spun backward, they could leap over nets, strike the dam face, and sink to the correct depth before exploding. The concept sounded absurd. Bombs were designed to fall, not dance. Yet Wallis persisted, running small-scale tests in reservoirs and ponds, Each experiment brought marginal improvements, turning ridicule into cautious interest within the Air Ministry. The bomb itself became a rotating cylinder, later nicknamed the upkeep mine. Released at precise height and speed, it would skim the surface, strike the dam, and roll downward underwater before detonating at lethal depth. Even with a workable bomb, accuracy demanded extreme flying skill. Pilots would have to maintain exact altitude and speed in darkness. No instruments could be trusted alone. The solution would combine mechanics, optics, and human nerve. By early 1943, skepticism gave way to urgency. Germany's war production surged, and the dams became strategic obsessions. The question was no longer whether the idea was strange, but whether it could be made reliable before time ran out. To carry out the mission, the RAF formed a new unit, 617 Squadron. Its crews were drawn from across bomber commands not by rank, but by skill. Night flying, low-level navigation, and calm under fire mattered more than experience in mass raids. Training was relentless. Crews flew at treetop height over reservoirs, skimming water at night. Mistakes were punished instantly. Aircraft clipped waves, engines strained, nerves frayed. Each rehearsal imitated the real attack as closely as possible. Two straightforward spotlights resolved the issue of altitude. Installed underneath the aircraft, their light beams intersected at the appropriate height. When the two illuminated circles aligned on the surface of the water, the pilot could be certain he was flying at an ideal low altitude. Distance posed another challenge. Bombs had to be released at a fixed range from the dam. Crews used a handmade wooden sight, aligning dam towers within a specific frame. Primitive, but devastatingly accurate when used correctly. Changes were made to the aircraft. The Lancaster bombers had their armor and guns removed to reduce weight. The bomb bays were modified to allow the spinning mine to be carried on the outside. Each modification sacrificed protection in favor of potential. The crews knew the odds. Flying low meant exposure to every gun and obstacle. Survival depended on silence, darkness, and discipline. Despite this, volunteers filled the squadron faster than planners expected. Wing Commander Guy Gibson was selected to head the operation. Youthful, self-assured, and seasoned, he earned the confidence of others. However, his position would not protect him from peril. During this mission, his rank provided no safeguard. By May of 1943, every preparation was finalized. The plans were fully developed, the aircraft refined to flawless standards, and all confidential details meticulously safeguarded. The only lingering unknown was the battle itself, a variable beyond the full control of any engineer. During the night of May 16, 19 Lancaster bombers ascended into the night sky. Their paths wound over the North Sea and into Germany, staying close to the ground to evade radar detection. Radio communication fell silent. Each crew was on their own. Almost immediately, danger struck. Several aircraft collided with power lines or fell to flak. The low-altitude strategy demanded perfection, and even small errors proved fatal. The mission continued regardless. As the remaining bombers neared their objectives, the valleys guided them toward fiery defenses. Beams from searchlights scanned the water. Tracer rounds streaked through the sky. The pilots dropped even lower, pushing against their natural instincts to stay alive. At the Modi Dam, the first attack runs began. One by one, aircraft lined up. Each pass demanded precise height, speed, and timing. Miss by seconds and the bomb would fail, or the aircraft would be lost. Early attempts failed. Bombs bounced wide or struck poorly. Defenders adapted, intensifying fire. Yet crews pressed on, learning from each explosion, refining approaches under fire. Finally, a bomb struck correctly. It skipped, impacted the dam face, and sank. Seconds later, an underwater detonation heaved the concrete. Cracks spidered across the surface. Another successful hit followed. The dam resisted briefly, then surrendered. A monstrous surge of water erupted through the breach, roaring down the valley toward towns and factories below. Similar scenes unfolded at the Eder Dam after repeated attacks. The Sorpe Dam resisted more stubbornly, absorbing damage but remaining intact. Victory, like loss, proved uneven. The floods swept through the valleys, wreaking havoc on homes, bridges, and factories. Electricity plants ceased functioning. Mines became waterlogged. Industrial production experienced a significant decline, confirming the strategic risk, at least for the time being. Weekends in Kampala, fit everybody, and making huge, allowed, bringing to DUS, another negative, and taking out the message to the valley, you always must fishing can. Misturating her need, right? He's got all these stuff about sheep, stump, but God had a kid, my dude. John of the should be out of this. Yeah, don't working this. Stop that. Sunday, I tell me that in the outlook, the element, bar now, you want me to build a truck down to Europe? Where you building? Yeah, that's the on. Yeah. He knows he not on it. That may. What? Yeah. Don't look. Yeah. So, watching for them. Out of the total of 19 planes, 8 did not make it back. 53 crew members lost their lives, and 3 were taken prisoner. Almost half of the squadron was wiped out in just one night, a heartbreaking loss by any standard. For survivors, celebration was muted. Success had been purchased dearly. Many wrestled with conflicting emotions, pride, grief, and a haunting memory of those who never came back. German authorities repaired the dams faster than expected, diverting labor and materials from other projects. Though temporary, the disruption forced difficult choices across the German war economy. Strategically, the raid proved that precision attacks could reshape targets once considered invulnerable. It foreshadowed future doctrines emphasizing accuracy over sheer volume. Yet Operation Chastise did not end the war, nor cripple Germany permanently. Its true influence lay in demonstration of innovation, courage, and restraint's limits in total war. The raid's legacy would soon outgrow its immediate results, shaping how history remembered these airmen and the strange bombs they carried. As a part of its legacy, Operation Chastise became legendary as the Dambusters raid. Accounts reduced it to acts of bravery and boldness, frequently overlooking its intricacy and sacrifices. Myth was simpler to recall than its subtleties. Barnes Wallis's ideas influenced later precision weapons and earthquake bombs. His belief that engineering could target structures, not cities, reshaped military thinking for decades. For the men of 617 Squadron, the mission shaped their entire lives. Some took to the skies once more. Others were forever tied to that fateful night. Remembrance became both a source of pride and a heavy weight to bear. Today, the dams still stand, rebuilt and reinforced. Calm reservoirs conceal histories of violence beneath their surfaces, a reminder that landscapes remember even when water smooths the scars. The 60 seconds that mattered most were never just about explosions. They were about preparation, belief in an impossible idea, and the human willingness to try. Operation Chastise reminds us that war is rarely clean, even when precise. Innovation can magnify both effectiveness and consequence, binding progress tightly to responsibility. In the end, the miracle was not just that dams were broken, but that humans learned to bend physics, fear, and fate, if only briefly, to their will. And so the story closes where it began, with water, steel, and seconds echoing through history, long after the waves fell silent.